Hi, my name is Sagi Monin, and I'll present to you a work of analyzing phase masks for wide etendue holographic displays. In near-eye displays, the viewer places his eye adjacent to the SLM, seeing the target image. The size of the viewed image is the field of view of the display, dictated by the maximum angle the SLM can produce. The eye box, which is where the viewer can place his eye, is proportional to the size of the SLM. The multiplication between the eye box and the field of view is known as the etendue and is proportional to the number of pixels. Current SLMs suffer from extremely limited etendue. Researchers have suggested that Étendue can be expanded by adding a static phase mask with a pitch size smaller than that of the SLM. We suggest analyzing Étendue expansion by examining the slopes of the DOE as they determine the angular range. We think of our DOE as a mask that locally tilts the illumination on the SLM. And in this work, we theoretically analyze Étendue expansion with DOE masks and ask what are the optimal design for such a DOE. We present two main results of our paper. Our first result shows that when considering 2D target images, the optimal mask is a quadratic phase mask. But this result is problematic. When solely optimizing for 2D content, we effectively assume that the pupil of the viewer is as wide as the eye box and simply integrates over all of it. But this prediction is very sensitive to the exact pupil simulated, and if the pupil is a bit smaller, image content disappears. We received this result since we optimized for an inadequate score, which considered only the formulation of a single 2D image. In the second result, we suggest optimizing for a light-filled image. Now, when the viewer shifts his eye along the eye box, the entire field of view is continuously covered and occlusion between the objects is updated. We showed that there exists an optimal DOE for such a light-field target, a lenslet array, with each lens as big as a pupil. This solution might look familiar as lenslet arrays are traditionally used in integral displays, but there's a big difference since the number of lenses is much smaller.